Okay, this is grade 10, grade 10, grade 10, grade 10, grade 10, grade 10. All right, so I hope that we've shared that, shared the live session to the relevant entities. I think, Utloche, I saw you share the live session to the relevant group. Thank you so much for that. So we are doing grade 10 mathematics. We just we're going to be starting very shortly, grade 10 mathematics. Yesterday we started with factorization, grade 10 factorization. We looked at highest common factor factorization, and we looked at grouping factorization. So we looked at highest common factor factorization, and we looked at grouping factorization. So today we'll actually be picking it up again just for our grouping, all right? Grouping factorization. We'll pick it up from there, all right? And maybe just quickly also go through some of the problems I had asked us to do for, I think it was homework, for our game challenge. So that we can cover bases on what we had been required to do. So I'm sure you guys can remember that this was the work that I had asked you guys to do, or let me say the game challenge I had asked that we do in preparation, so that we can actually internalize what we learned in class. Remember, people, don't take this thing in that attitude you usually take homework for whenever you are given it at school. These are game challenges. They're supposed to help you to internalize what you've learned. Okay? Yeah. So please, just something I wanted to say from the beginning, the get-go of this lesson. Something I've noticed just with some other individuals. You know, guys, when you haven't done something for a very long time, you do tend to not be good at doing that particular thing. I hope you guys are hearing me. So some of us get bothered by when a term opens and we go back into doing the things that we used to do so well in. Let's say maybe last year you were so good at something, but now all of a sudden you are not as great, and you can feel that it's taking a long time. Remember, you had a very long holiday. And if in that holiday you were not touching what you are usually good at doing, what's going to happen is that you are going to find that it's going to take you some time to get back into the swing of things, where things start being easy again, where things start to be the way that they used to be. So you need to be patient with yourself then, you know. But what's nice with the people that are joining in the session now, they are getting shocked that, hey, I've forgotten how to do certain things. But at least you are getting shocked before the school term actually officially begins at your school. So hopefully by the time you go back to school, then the shock will have gone, and in actual fact, you will have gotten back to your winning ways. All right. We need to become those kinds of maths learners that retain and keep the maths content, the excellence of the maths content that we gained. We need to keep it for a longer time. That only really comes through engaging with the maths and doing the problems. You can't just watch me doing the maths and be like, it makes a bit more sense. You need to give yourself the time alone and do it. Face it on your own. Do it on your own. And then be able to see, where you need to improve, where you need to get better, and so forth. So please, people, let's get these game challenges done. Let's do them. Let's not do them. So I'm sure you guys remember from yesterday. What did I say whenever we are factorizing? First step, we check how many terms do we have in the expression. It's very important to do that. How many terms? Okay, you being able to ask yourself that question will help you be able to see, okay, I still understand as a grade 10 learner that terms are separated by a plus and a minus sign. So how many terms in the expression? We have 2. That's where we start. Then the second thing we need to ask ourselves, according to the sign, according to the number, according to the letter or the variable, what is the highest common factor? And you remember I said yesterday that for the sign, we always look to the first term. Right? So firstly, are these like terms? No, they are not. So because they are not like terms, we really truly only have 2 terms, and they are really separate because the variable here is x, the variable here is x, and the exponent here is 2, the exponent here is 5. These are unlike terms. Maybe that's a question we need to also ask ourselves. Firstly, we ask how many terms. Obviously, there's 2. Second question, which is probably good to ask, are there any like terms? So even before you factorize, are there any like terms? So obviously here you can see there are no like terms because this is an x squared term, even though this is also having an x, but the exponent is different. That's what makes them unlike terms. Then 3, identify the highest common factor sign. So this is a positive 15x squared, this is positive 9x to the power 5. And you remember yesterday I said that the sign that we take out as our highest common factor will always be the sign of the first term. That is the highest common factor sign. So the highest common factor sign is positive, but whether we write that positive down or we don't, the absence of a sign means the sign is positive. Then we need to check what is our highest common factor number. So between 15 and 9, what is the highest common factor number? The highest common factor number between 15 and 9 is 3. Then what is the highest common factor variable or letter? Between x squared and x to the power 5, we know that whenever we identify the highest common factor for our letter, we go for the base that has the lowest exponent. The highest common factor variable is always the base with the lowest exponent. So 3x squared is our highest common factor. We write it outside and then inside the bracket, okay, to identify the terms inside the bracket. Okay, 15 divided by 3, the positive times of what gives me a positive, it's still positive. 15 divided by 3 for the number is 5. Or in other words, what's 3? 3 times what gives me 15? It's 5. Then x squared was taken out. I need x squared to be in the final answer. Do I need to multiply by something that has x? Definitely not. So this is 5. The term on the left hand side is 5. A positive times what gives me a positive? It's still a positive. Then 3 times what gives me 9? It's 3, or in other words, what's 9 divided by 3? I get 3. X squared, there are 2 of my x's. I need 5 at the end. How many x's do I need to add to the 2 to get 5? It means I need to add 3 of these x's. Because when bases are the same and I'm multiplying, what do I do to the exponents? I add the exponents. So that is 5 plus 3x to the power 3. Factorized. If you look at the brackets, inside the bracket, can I factorize any further? Is there something to be factorized any further? No. So therefore my final answer is 3x squared into 5 plus 3x to the power 3. Okay. Hope I'm making sense to someone and I'm speaking truth to someone. Are we together? All right. Okay. So that was a correction that you should have. I mean, that was nothing much to it. 15a to the power 4b to the power 6 plus 3ab to the power 2. All right. Again, how many terms? There are 2. Are there any like terms? No, because this is 15a to the power 4. This a is raised to the power 1. This is b to the power 6. This is raised to the power b to the power 2. So these are unlike terms. So we can go ahead and factorize. Highest common factor sign, we always take the sign of the first term as our highest common factor sign. Highest common factor number between 15 and 3. What is the highest common factor? It is 3. Highest common factor variable, a to the power 4 and a. Which base has the lowest exponent? It is a. B to the power 6 and b to the power 2. Which base variable has the lowest exponent? It's b to the power 2. Alright, then it means we open the bracket. So this is our highest common factor outside the bracket. Then 15 divided by 3. Obviously this is what we have. It's positive. Positive times what gives me back a positive? Then obviously the first term in the bracket will be positive. What's 15 divided by 3? Or 3 times what gives me 15? 5. I have 1a out. I have 4 that I want at the end. How many a's do I need to add to this one? It's 3 of them. Alright? Then b squared. I have 2 of these b's. I have 6 of them that I want at the end. How many do I need to add? I need to add 4 of them. And then positive times what gives me a positive? The sign will still be positive in the middle. Then 3 times what gives me 3? Obviously that is 1. A, I have 1 that I took out. I need 1 at the end. Do I need to add any more a's? No. B, I took 2 b's out. I still need 2 at the end. Do I need to add any more? No. So that means my final answer is this. Okay. Yeah. Hopefully it's flowing, guys. It's flowing. All right. Now, I am not going to finish off the rest of the problems that I had put up for homework. Okay. I am not going to finish the rest of the problems that I put up for homework. Okay. Because I want to allow people the opportunity and the chance to be able to do those on their own if they have not done them already. And there the picture is, you can screenshot and then you can do on your own as a grade 10 learner, because I want to do the next concept. If you missed out on yesterday's lesson on this, you can always go to my YouTube channel, Maths is a Game, and you can watch the video lesson that I posted from yesterday. It's already there, grade 10. You see the thumbnail. You go to my bio, you click on the link for the YouTube channel and you can go watch that video. It will be worth your time. I'll just take one other problem here, just so that maybe let's just say 2 more, 5 and 7. So let's look at 5, just so that we can see. So 5 is this one, negative 3y minus 6x. How many terms in the expression? There are 2 terms in the expression. That's the first question. 2. Are these like or unlike terms? They are unlike terms. So it's still 2 separate terms. Then we take out the highest common factor sign, followed by the highest common factor number, followed by the highest common factor letter, if there is any. So highest common factor sign, the first term is negative, so we usually take out the sign of the first term as our highest common factor sign. Are you with me? Then we go on to the number. Between 3 and 6, what is the highest common factor number? It is 3. Between y and x, do we have a highest common factor variable? No, we don't. So we open the bracket. Then what do we write on the left? Negative times what gives me a negative? It's positive. 3 times what gives me 3y. So that means I need to write y, and it's positive 1y. That is my first term. On the other side, negative times what gives me a negative? Be very careful, guys. Whenever you take out a negative sign, it changes every single sign inside your bracket. Remember, the first term was negative, now it's positive y. But the second term was negative, now it will be positive. Okay, be very careful. Then 3 times what gives you 6? It's 2. There was no x taken out, but I need an x at the end, so do I have to have an x? Definitely. And that basically leaves me with this answer as my factorized state. Please, guys, take this one step at a time when you are given factorization of this nature. Please, I beg you, please. Please. Okay, and I'll do number 10 so that we can also check the grouping that we did yesterday. Right? The grouping that we did yesterday. 3pq plus 3pr minus 4mr minus 4mq. Let us look at this particular problem. How many terms in the expression? There are 4 terms. Right? So, in other words, we have an even number of terms. There are 4 terms. It's an even number of terms. Now, do we have a highest common factor for all 4 terms? Yes, we do. It's 1. But does 1 change anything? It doesn't, guys. If we take 1 out, we'll still have 3pq plus 3pr minus 4mr minus 4mq. So, we're not going to take 1 out, So that means we need to look at something else now. Since we have an even number of terms, it means we are not going to approach this problem as a highest common factor type problem. We are going to approach it because we can clearly see that in this even number of terms, we can actually identify a pair of terms and take out a common factor for the pair that we identify. Now, as the terms appear, all 4 of them, I'm sure you guys can see that these first 2 terms, there is a visible highest common factor that you can take out. And then for these 2 last terms, there are visible common factors that you can take out. All right? So for me, in my head, you first identify the pair of terms. For your even number of terms, you identify the pair of terms where you can clearly see that there's a common factor, right? And you identify that pair according to what you can sort of like foresee, because you want to have a common bracket for when you factorize for the respective pair of terms. So 3pq plus 3pr, if you look at these 2 terms, all right? Yeah, I've just grouped them by doing this. I know some people, what they do, they usually put brackets. They'll put a bracket over around 3pq and 3pr. Please, people, if you do that, I want to just indicate the following, and I want to write this out because it's very important. If you are a person that likes putting brackets around, you need to do the following when you do that. Putting the brackets, because the reason why you are putting brackets is because you want to actually say these are the pair of terms that I'm identifying. That's why you are doing that. So if you do this, please put the bracket. You see the first two terms? I've put the bracket around the first two terms. Then the last two terms, the first term in my last two terms has a negative. Put the bracket even around its sign, all right? And then in between, put a plus sign. Please, I beg you. In between, put a plus sign, all right? So that you can show that there's a separation, all right? That's if you are someone that puts brackets. But if you don't put brackets and you just identify the pair of terms, then obviously you can just proceed and factorize, all right? Because the separateness of the terms is still retained if you don't put any brackets. Okay, so let's go. 3pq plus 3pr. What is the highest common factor between these two terms? So let's look at the sign. The highest common factor sign is positive. Then secondly, number between 3 and 3, it is positive 3. Then P and P, then obviously P is common. Q and R, there's nothing that's common there. So that means our highest common factor is 3P. So we are ready now to open a bracket. 3P plus what gives me 3PQ. So on the left, I am left with Q. Plus 3P times what gives me 3PR. That means I'm left with R on the right. Okay. Then for your last two terms, you have negative 4MR minus 4MQ. So for the last two terms, your first term for the last two terms has a negative. So what do we do whenever we have a negative sign for our first term where we are trying to factorize? We take out the sign as a highest common factor. The term, this first sign, we take it out as a highest common factor. Okay. Then between 4 and 4, what is the highest common factor number? Thank you, Samke. Thank you. Between 4 and 4, what is the highest common factor? It is 4. We take out 4. Then MR and MQ. Between MR and MQ, we look at M and M. M is a common factor. Then R and Q are not common. So that basically means we are done with taking out a common factor. It's negative 4M for the last two terms. Then we open the bracket because we have taken out the common factor. On the left side, negative times what gives me a negative? Obviously, the number inside the bracket will be positive. Are you with me? Then 4 times what gives me 4? Obviously, it's going to be 1. Then M is already taken out. I need an M at the end. Do I need to add any more M's? No, I don't. R was not there, taken out. So R needs to appear for my first term inside the bracket. Then again, we go to the last term. Negative times what gives me a negative? For the second term, it is positive. Then 4 times what gives me 4? Obviously, that is 1. And then M times what gives me MQ? Then that means that is Q. We close the bracket. All right. Now, what do you notice, guys? We have Q plus R, whereas this side we have R plus Q. What we have now is how many terms in total? Hopefully, you guys can see that this is our first term, because remember, terms are separated by a plus and a minus sign. So 3P into Q plus R is one term. And then 4M into R plus Q is my second term, separated by the what? By the minus sign. So yes, we have 2 terms. But what do we notice about these 2 terms? We notice that the brackets, here we have Q plus R. Here we have R plus Q. Okay? And honestly speaking, people, Q plus R is the same thing. Q plus R is the same thing as R plus Q. Are you with me? Yeah, because 1 plus 2 is also equal to 2 plus 1. If you change the order for positive, 1 plus 2 is the same thing as 2 plus 1. So changing the order for addition does not change the answer. That's why we say addition is commutative. The order in which you decide to place the numbers when there's addition will not change the answer. So Q plus R is the same thing as R plus Q. So on the left we have Q plus R, on the right we have R plus Q. So for addition in this bracket, these are the same. So what we can do, we take R plus Q as a common factor. Are you with me? Because we are factorizing. We take R plus Q as a common factor. The minute we do that, if you hide R plus Q on the left, what are you left with on the left hand side? What's exposed? It's 3p on the left. If you hide R plus Q on the right, what is exposed? Negative 4m. Okay, and that is done and dusted. Okay, so guys, this is basically how we go about factorizing, where we have a situation where there are an even number of terms, and clearly from this even number of terms we cannot just simply take out the highest common factor and have factorization happen. The highest common factor is 1 for the whole 4 terms. Therefore it means we need to then look into a certain pair of terms, and then we group those terms, we take out a common factor so that we establish common brackets. And then from those common brackets, because they are common in this situation, we take out the highest common factor bracket, which is a binomial, which is R plus Q in this situation. And then when we take that out, we ask ourselves, what is left on the left? It's 3p. What is left on the right? It's negative 4m. So therefore our factorization is R plus Q into 3p minus 4m. Okay. Right, so this was just me reviewing what we did yesterday, and I repeat again, if you missed it yesterday, the YouTube channel is there for you to go and re-watch the entire session and segment, so that your factorization for grouping is not compromised. Your factorization for grouping is well and good. All right. Right. Now, before I get deep into what I want to cover today, I want to look at another type of highest common factor factorization, but with binomial brackets. And I just want to check, I want to basically cover this section as well, so that we are not at loss whenever we are given a situation of this nature. So I'm just going to write the question down here. X minus 7. Sorry, not x minus 7. X minus 1. The whole thing to the power 7 minus x minus 1. The whole thing to the power 4. Okay. Now, if you look at this question, this here is not saying we must expand or simplify. It simply says factorize. Okay. Now, before we jump into this, just take note of something. If I had given you a problem like this, and I said to you factorize, okay, this is a to the power 7 minus a to the power 4. Okay, so firstly we ask, how many terms do we have? We have 2 terms. Are these like terms? No, they are not. They are unlike terms, which means we cannot subtract them. So when we factorize, we know that whenever we factorize, we take out the highest common factor, if there is one, according to the sign, according to the number, according to the letter. So my question is, first and foremost, what is the highest common factor sign? Obviously, the first term is positive, so the highest common factor sign is positive. But remember, writing that positive down for a highest common factor and its absence still means that our term is positive. Are you with me? So the highest common factor sign is positive. What about the highest common factor number? Between 1a to the power 7 and 1a to the power 4, our highest common factor number is 1. And then lastly, the letter. What's the highest common factor letter? Remember, when we take out the highest common factor variable, we go for the common base that has the lowest exponent. So that means our highest common factor variable is a to the power 4. Now what are we left with? Once we take out the highest common factor, what are we left with in brackets? We took out 4 of these a's. We need 7 at the end. So how many do we need to add to get 7? We need 3 of these a's, right? So it's a to the power 3. Okay. Then on the other side, positive times what gives me a negative? The sign is still negative. Okay, this is grade 10. And then a to the power 4 times what gives me a to the power 4. All right, that is actually equal to 1. Because remember, a to the power 4, we've already taken out a to the power 4s. We need a to the power 4s at the end, but basically we cannot add anymore. So a to the power 4 times what gives me a to the power 4? It is 1. So then that's the answer. Our final answer is a to the power 4 into a to the power 3 minus 1. Okay, remember, we have not covered all the other types of factorization. So if you are a grade 10 learner and you've just started doing factorization, you've done highest common factor, you've done grouping, then basically this is where you would end as a grade 10 learner who has learned that much so far. Okay. Someone else is looking at this and they are in another grade and they're like, but sir, you can continue further. Yes, I can continue further, but only if I have learned that content of cubic factorization. We are still getting there. Okay, so hold your horses. So this is the answer when we factorize. I hope we are all together. This is how we factorize this. Please take your attention and look at this. Okay, x minus 7 to the power, x minus 1 to the power 7 minus x minus 1 to the power 4. So if we look at this expression, how many terms do we have? Let's start there. How many terms do we have in this expression? And I hope people can answer in the comment section. How many terms do we have in this expression? Klochi says 2. Drip as well. Busi says the same. Okay, good. I'm happy that we all are saying 2. Because we remember most from grade 9 that brackets combine terms. So this is one term minus separates, and then this is another term. It's one term. So it's 1, 2 terms. But can you notice something about these 2 terms? X minus 1 and x minus 1 are common bases. But it's just that they are binomial bases. X minus 1 and x minus 1 are common. So would you all agree that x minus 1 is a common factor binomial? Can we see that, guys? Common factor binomial. X minus 1 and x minus 1 is a common factor binomial. Okay. So if we were doing the whole sign number letter, if we take out the highest common factor sign, if we look at this term and this term, the highest common factor sign for x minus 1 to the power 7 and x minus 1 to the power 4, the highest common factor sign is what? Is positive. I hope we can agree with that. Because this x minus 1, the coefficient of the bracket is positive 1. The highest common factor number, this has a 1 outside, this has a negative 1, but the first term, x minus 1 to the power 7, has a positive 1. So the highest common factor number would be 1. I hope we are all together there. Then the variable or the letter is actually a binomial base. This is one term the minute it is in bracket raised to the power 7. But what do we notice? X minus 1 is a common binomial base. Okay, so for our variable, we are going to say in brackets x minus 1 is our common letter variable. But remember, since it's the common binomial base, look at the exponent. This one is raised to the power 7. This one is raised to the power 4. So when we identify the highest common factor base, which is a binomial, we are going to go for the common binomial base that has the lowest exponent. So when we are identifying our highest common factor, we are identifying x minus 1 raised to the power 4 as our highest common factor. I hope we are together here and we are feeling it, because it's very important. All right. Okay. So we have a highest common factor bracket because it's common for the two terms. X minus 1 is common, but we always go for the common base that has the lowest exponent when we are identifying the HCF. So check this out. So what I do is I take out that common factor, which is x minus 1, the whole thing to the power 4. I take it out, but when I take it out, it has to be in brackets to the power 4 because that is the base that has the lowest exponent that I take out. What is left inside? What is left inside? If I took out the x minus 1 to the power 4, I took out 4 of these x minus 1s. On the left, to get 7, how many do I need to make sure are available? It means I'm going to make sure that how many of these 4s do I need to add to get 7? I need to add 3 of them. Are you with me? So I open a bracket. This major bracket is for what I'm going to house inside. But remember, because it's a binomial expression raised to the power 4, that is my highest common factor, then obviously what is left is x minus 1 to the power 3. Right? Because these bases are the same. When the bases are the same and I'm multiplying, I keep the base, I add the exponent. So 4 plus 3 will give me back the 7. Okay. If you are with me and we are together, then please you can comment in the comment section and say level 7. Okay. Yeah. Level 7. You can see even the exponents, they are crying for us to say, but level 7 is possible, guys, because you can see 4 plus 3 is 7. It's almost as if it's like fate. Okay. All right. Now, that is for our first term. Our first term is sorted. Let's look at the last term, x minus 1 to the power 4. Guys, this is x minus 1 to the power 4. Times what will give me negative x minus 1 in brackets to the power 4. This times what will give me back this. But let's look first at the sign. A positive times what gives me a negative. So the sign is still what? Negative. Because remember, when I took out the sign, I took out a positive 1. Remember, this is like, I can write this 1 into x minus 4. I mean, even if we don't write the 1 is there. Are you with me? So this is minus 1. You close the big bracket. Take note of my brackets here, guys. Take note. Okay. This is my answer. Okay. This is what I refer to as highest common factor binomial brackets. They are sometimes there in the questions, and sometimes people just miss them. It's another way of factorizing, but this time round with a monomial that is a bracket. Remember, we say this is one term. So just like we are saying a to the power 7 is one term. Are you with me? So this is also one term. This is another term. Thank you, Ma'eo, for the rose. I really appreciate it. Okay. I hope we are together here. All right. Let's look, because this is finished. This is done and dusted. Okay. Usually, sometimes in mathematics, when we have factorized this, sometimes mathematicians do this. They use square brackets. I hope you guys can see this. They use square brackets so that you guys can distinguish distinguish the bracket for the terms inside the bracket itself, and then obviously this smaller nyana guy, the binomial, So whether you choose to use big brackets or use square brackets, that's entirely up to you, all right? Yeah. Okay. Yes. Don't worry about that one. Yeah. Don't worry. Just stick to this. You can see what we are having here. Stick to this one, okay? All right. Let's look at another example. All right. Let's look at another example. M minus n to the power 6 plus m minus n to the power 3. Okay, so again, guys, look at this. How many terms in the expression? We have 2 terms. Okay, hopefully we are all rogered with that. Then 2. With these 2 terms, is there anything we can do with them? Can we add anything? No. So the question is saying factorize, right? Yeah. So if we are going to factorize, what we are going to do is we are going to look at this term and look at this term. Are the bases common for our binomial? Once again, we have m minus n, we have m minus n. These are common. Are you with me? So we are going to take out the highest common factor according to the sign, according to the number, according to the letters, the binomial bracket. So obviously we know that we have this is positive. So it's a positive, that's a sign, and the number is 1. Whether we write the 1 or we don't, we know the 1 is there, even if we don't see it. Then we take out the variable. The variable is m minus n. Take note, we put the bracket. Now, which exponent are we going to write there as our exponent? When we are talking about taking out the common base for highest common factor, we take out the common base, m minus n, that has which exponent? Which has the lowest exponent. So it will be to the power 3. Thank you, Busi. Okay, then can you decide, are you going to use square brackets or the big brackets? That's really up to you. It doesn't really matter, guys. Okay, remember there's no sign in between this. Okay, the bracket. Okay, whether you use square or whatever. Then I'm going to write a smaller bracket here for the term that's binomial that will need to be multiplied to m minus n to the power 3. Now m minus n will still appear, but if I have taken out 3, how many do I need to add of m minus n's to get 6? I need to add 3 of them. Maybe you guys are listening to me say, how many m minus n's do I need to add? Remember, I am remembering that in mathematics, whenever we are looking at exponents, if our bases are the same and we are multiplying, in exponents we learned that if the bases are the same, we keep the base and we add the exponent. So 3 plus 3 will give me the 6. That's why I'm always asking, how many of these m minus n's do I need to add to this number to get the 6 that I want? I add 3 of them. Are you with me? Then this m minus n, since it was positive, it will not change the sign of this positive. It will still stay the same. Then inside, what do we have? M minus n to the power 3. That means m minus n to the power 3 times what will give me back the m minus n to the power 3? Okay, it's 6, ne? It's 6. It will be 1. Then I close my big bracket. Then we can say we are done for now, all right? Because as far as what we have learned as grade 10 learners, we have only learned highest common factor factorization and grouping factorization. We have not learned any other type as of yet. So we stop right here for now, all right? Obviously, later on, things will get better and bigger and will be sweeter and smarter and cooler, all right? Okay. Hopefully, we are getting the mojo of this thing and it's flowing very nicely, okay? Now, I want to turn now my attention away from this and look at something else that we refer to as the sign change rule in grouping. And for that purpose, I'm going to look at another example for us very quickly. And in this example, hopefully we can appreciate what has been done. Okay, so hopefully this one, we saw what we needed to see, all right? It's so important to always look at the question and check what we have in that question so that we can move and flow with what we have there. So check this question out. 4x into a plus 3 minus 2 plus 2 minus a to the power 3. Okay. Now, grouping, or let's say common bracket. Okay, when you have a common bracket situation. Let's look at this question. Once again, how many terms do we have in this expression? Hopefully you guys can see how many terms we have. There's 4x into a to the power 3 minus 2 plus 2 minus a to the power 3. So see where you are right. We have 2 terms, right? This is 1. The plus separates this term. This is 2 terms. Sweet. Next question. Is there anything that we can say is the highest common factor for the 2 terms? So I'm sure for now you can see, hey, it's 1 is the highest common factor, but 1 doesn't change anything, right? The sign is positive, and positive 1 won't change anything. So it leaves us still in the same situation. So let's hold our horses then. It means there's nothing. So there's something that we need to take note of. If you look at the bracket, are the brackets even common? A to the power 3 minus 2. Here we have 2 minus a to the power 3. Are these the same thing? Is a to the power 3 minus 2 the same thing as 2 minus a to the power 3? Could we say these brackets are common? Are they? No, these brackets are not common. Okay, and maybe to help us further explain why we say they are not common, it's because, guys, if you for instance look at 2 minus 1. 2 minus 1 we know is equal to what? To 1. I'm sure you guys can see that. Whereas 1 minus 2 on the other hand, if you take this one, you put it first, you take the 2, you put it last, and you put the minus sign as it is. What is 1 minus 2? 1 minus 2 is equal to negative 1. So you can clearly see that the answers will not be the same if the sign in between is actually negative. Does that make sense? Very importantly, I hope it does. But what would happen if we took this 1 minus 2, if we took this 1 minus 2 and we did the following, okay, actually let's hold that thought. Okay, let's hold that thought. So 4x into a to the power 3 minus 2 in this bracket plus 2 minus a to the power 3. So in grade 9, you guys should have learned what we have come to know as the sign change rule. So when terms inside the bracket have the variable first and then the constant term last, we are on good ground. If we look at this, we want to change this 2 minus a to the power 3 so that it resembles a to the power 3 minus 2. Okay, so let's go ahead and do that. Let's write a to the power 3 minus 2 and write the order the same as the order of the first term. So we have a to the power 3 minus 2. We apply then something that we refer to as the sign change rule. This positive sign here changes to a negative sign. In fact, this is what we do. You change the sign, you change the order. You change the sign, you change the order. And maybe you're going to ask why, say, look, if I took this negative and multiplied into this bracket, what I want to check is, will I get this 2 minus a to the power 3 back? So if I take the negative and I multiply it with a to the power 3, what's negative times a to the power 3? Doesn't it give me negative a to the power 3? Yes, it does. If I take this negative and I multiply back into negative 2, does it give me this positive 2 back? Yes, it does. So we apply what we refer to as the sign change rule. We call it that. This always assists us to be able to write an expression that was initially written in the order that we see in a different order, while still maintaining the integrity of the expression. I repeat, when we change the sign outside of the bracket, it allows us to swap the the terms inside the expression, inside the bracket, while still maintaining the negative sign in between. So this a to the power 3, you just write it this side as positive. And then this 2, you write it this side, okay, as it is, you see? And then you change the sign outside that bracket so that it still maintains the very same identity that it had initially. We call this the what? The sign change rule. We apply the sign change rule only when there's a minus sign in between two terms. Please, people, we apply the sign change rule only when there's a minus sign between two terms. And if we are interested in changing that expression so that it resembles or is the same as the expression in the first bracket. Please, people, even if, let's say it was the other way around, if we wanted to change this to become 2 minus a to the power 3 like this one, then we would keep this positive and say 2 minus a to the power 3. Then what would we do to this 4x? We'd change this 4x to negative 4x, then change the order, 2 minus a to the power 3, if we wanted to do it that way. But by convention, we stick to the variable first in our bracket, and then the constant term follows. So by convention, we retain the variable term first, meaning the letter term first, and then the number next. So to change this with the letter first, a to the power 3, the number last 2, we change the sign before that specific bracket. The sign of the sign of whatever is before the bracket changes, then it allows us to change the order of the terms. I hope we understand what the sign change rule actually means for our factorization. Now that we are here, I can ask the question again. Do we have a common thingamabob that we can take out? A common expression? A common bracket? Now we definitely do. Alright? Okay. So that common expression that we take out is a to the power 3 minus 2. We take that out in brackets. Then what are we left with on the left? It is 4x. Okay, do you see that? If I hide the a to the power 3 minus 2, which I took out, what am I left with on the left? 4x. So I write the 4x first as the first term inside my bracket. Then if I hide this a to the power 3 minus 2 on the right side, what am I left with on the right side? I'm left with negative. And remember, there's a 1 there. It's always there, even if you can't see it, guys. You see, there was no 1, but the 1 is always there. Okay, and we close the bracket. Can we factorize any further according to what we've learned so far? Definitely not. So we leave our answer in that state. Can you feel me, brothers and sisters? Can you feel me? Are you with me? Okay, all right. Yeah, that is very key to be felt. To be felt is a very important thing. When people feel you, you also feel yourself. Thank you, my friend. I see you really feel me. All right. Okay. I just want to do one more example. One more for this type of factorization. Maybe I'll hold it right there for today. Then I'll continue on with the other types of factorization tomorrow. I'll leave you guys with game challenges for this so that you guys can also feel yourself out and see how it is you are doing, and if things are good. All right, let's look at this example. Okay, just hold on. Okay, so once again, we look at this expression and we ask ourselves, how many terms do we have in the expression? There are 2 terms, standard. 2, do we have any like terms? No, we don't. So basically, we don't have like terms, inside the bracket, nothing. 3, do we have any highest common factor? Now, this is a critical question. Do we have any highest common factor? Now, guys, I'm sure you can see that the brackets are not the same, right? Right? But we look at this bracket, the alphabetical order A followed by B, which is fine. Look at this one, B minus 3A. There's a minus sign in between. So that means we can apply what we've just learned recently, which is called the sign change rule. Why? Because we do have a negative sign for both these brackets, all right, which is important. But also, if you look at the terms outside the bracket, guys, do you see the terms outside the bracket? This is 2x squared for this term. This is 4x for this term. Which means, in actual fact, for the entire expression, we actually do have highest common factor signs, highest common factor number, and a highest common factor variable. So we could, if we wanted to, there's 2 approaches that we can actually take in answering this question. So I'm going to first look at this approach, and then I'm going to look at the other approach as well. Let's look at this approach. So someone who's like, okay, if I look at this problem, I'm like, okay, is there a common bracket? No, there isn't. So let's apply the sign change rule then. So we write 2x squared into 3a minus b. Now remember, this is negative 4x. Okay, this is b minus 3a. We want to get the expression to be the same inside the bracket. So 3a minus b is the model of perfection. B minus 3a needs to change his ways so that he follows the model of perfection, which is 3a minus b. So if b minus 3a is to be changed, what does that mean for our negative 4x? We need to change that to plus 4x. The sign of the outside sign changes from negative to positive because we are applying the sign change rule. Then we can change the order whilst retaining the sign that is negative for our bracket. Now I'm sure you guys can see, 3a minus b and 3a minus b. We are good. We are so good. All right. Now. Let's hold. So what is our highest common factor? Now, because we have applied the sign change rule helped us now so that now we can actually identify the highest common factor. Can you guys see what the highest common factor is for our 2 terms? The highest common factor sign is obviously positive, right? Because our first term is positive. The highest common factor sign is positive. The highest common factor number between 2 and 4. Okay, so this is, like I said, this is one method that we can use. Between 2 and 4, what is the highest common factor? Between 2 and 4? The highest common factor between 2 and 4 is 2. Thank you very much. The highest common factor between x squared and x, we go for the base that has the lowest exponent, so it's x. And then the highest common factor bracket, 3a minus b and 3a minus b. The highest common factor bracket between 3a minus b and 3a minus b, obviously 3a minus b is what? It's common. I'm sure you guys can see that. Okay. So I repeat, Highest common factor sign, positive, and positive is positive. Obviously, the positive sign for the first term, we always take the sign of the first term, 2. X squared and x, the highest common factor between x squared and x, we go for the base that has the lowest exponent, it's x. 3a minus b, 3a minus b, the highest common factor between 3a minus b and 3a minus b, it's common, so we write 3a minus b. Then, that's the highest common factor we've done. What is left on the left side? If we look at the left side, what are we left with? 2 we took out. We have 2 already. We don't need another one. X we took out. We need to have 2 of these x's. So what do we need to have there? We need to have x. 3a minus b we took out. Okay, we already have 3a minus b, we don't need to have any other. So that means our left number or our left term is x. Now let's go to this side. We took out 2x, it was positive, positive times what gives me back a positive? It is positive. Then x was taken out. I need an x. Do I need to add another one? No. A minus b was taken out. Alright, do I need another a minus b? No. But 2 times what gives me 4? If I look at the number, 2 times what gives me 4? It is 2. So I have a numerical value. 2 times what gives me 4? It's 2. X was already out. I don't need x. It's 2 times 1. Obviously, a minus b as well is another multiplication of 1. So basically, this is my factorization. This is one method. Alright, where we are taking out the highest common factor first, and then we write what's left on the left and what's left on the right. Okay, this is one approach one can use to be able to factorize this. Okay, so I hope this approach is fine for some of you. Okay, or alternatively, we can look at this approach. Okay, so let's take it from where we actually were able to fix the order. Okay, let's take it up from where we were able to fix the order. So we obviously had this initially. We changed the sign of the negative to positive. And then what did we do after that? B minus 3a, we changed the order to 3a minus b. So here's another approach. Someone else, instead of like identifying the highest common factor for everything, would basically maybe come here and see, oh, 3a minus b is a common bracket. So what do? Is they take out the 3a minus b, okay, which is perfectly fine. I hope we are together, né? And then, if you hide the 3a minus b, what are you left with on the left? You are left with 2x squared. If you hide the 3a minus b on the right, what are you left with? You are left with 4x. Okay? But then, guys, we are not done. If you look at this bracket, okay, the highest common factor is 1. I mean, we don't have to do anything. If you look at this bracket, you can factorize this bracket further. Okay? So that means we continue here, because we have to factorize fully. So for 2x squared plus 4x, what is the highest common factor between 2x squared and 4x? The sign that we take out would be positive. The number 2 and 4, what is the highest common factor between 2 and 4? It is 2. The letter between x squared and x would be x. Are you with me? All right. And then what are we left with inside the bracket? I'm sure you guys can see what we are left with inside the bracket. We are left with x plus 2. Okay. And there it is. There it is. Now, you're going to look at this and be like, 3a minus b. Remember, the relationship between these is multiply. Okay. So, for the purpose of order, remember multiplication is commutative, which means the order of the multiplication of this doesn't matter. But for the sake of order, we take the 2x at the front, we can follow it up with the x plus 2, and we can follow it up with the 3a minus b. We still basically have fundamentally the same what? The same answer. We just need to remember that we must factorize the expression that is given fully. We can't get to a place and still have things that are unfactorized. Right? So factorizing fully means we would have to factorize this particular bracket. When we do that, we take out the highest common factor between 2x squared and 4x, which is 2x. The relationship is still maintained of multiplication between these respective bases. Are you with me? So you take out 2x, what are you left with inside the bracket? You are left with x plus 2, and then you can reorder the terms. Or you could even leave your answer like this. This would still warrant you to get the full marks. Okay? Alright, guys, I'm going to hold it right there for grade 10 for today. So far in our factorization for grade 10, we've looked at highest common factor factorization, right? And we've looked at grouping type factorization. Then we've looked at also different types of scenarios where these are concerned. So I would encourage you then to please go to the YouTube page if you missed out on the other sessions, and you can actually do those. So here is your game challenge, so that you can see and check if you are good. Right? Here is your game challenge. I don't call it homework, I call it game challenge. Hopefully that way it fools your brain into thinking. I know how you guys think of homework. The minute someone, even in school, you say the homework is, people just have this, I don't know, this negativity flows in for most people. The minute you hear homework, problems. All right? So let's factorize fully the following problems, and I'm going to try very hard to make my writing as a little bit more romantic than it usually looks, so that people can have interest. Okay, so please guys, let's do these. Let's do all of them. Sorry, I just want to check something very quickly here. Yeah, because practice makes perfect. Practice makes perfect, and it makes permanent as well. If you want to permanently store what you've learned, then you need to do the problems, and then please, you can take pictures and send me on TikTok when you've done the problems, and I can check your work. Okay, don't have a problem with that. So the instruction is factorize, ne? Please, let's not be confused. We are not multiplying out or doing products now. We are doing factorization, and it's completely different from products. Okay, sorry, that one. So this is a plus c to the power 4. No matter what may come my way, my life is in your hands. Hopefully we know that our life is in his hands, irrespective of what may be happening. The month of January that we are entering into, we must know that we can stand because our life is in his hands. Hopefully we can commit that life into his hands so that no matter may come our way, things can, be good, you know. This is 7x to the power, 7x into m plus 3n plus 4y into negative m minus 3n the bracket at the end, ne? 9. Okay, this is 2x squared into 7a minus b minus 12x into b minus 7a. Ten is the lucky number, guys. 10 is the lucky number. Okay, here we go. This is A, sorry, so that is A. I'm sorry about that. This is A minus 3B, okay? A minus 3B brackets minus C, okay? Into 3B minus A, close brackets, plus D into 3B minus A, right? So, okay. All right, so yeah. So guys, please, you can do the game challenge on your own. I'm not going to be asking you to write the answers and give me the responses here. Do the problems, do them. You are more than welcome to send me a picture. I will check it out and see if you are doing okay, you are doing well, right? It's always those learners that actually do the work and show me what they are doing, that I can actually see what they are doing, and there's progress with them. But those who simply want to just come and chill here and watch me do the maths, I mean, you are just seeing me do what I know how to do. But do you know how to do it? That's the $1 million question. We need to get to a place where you are also able to do it so that you can be crops, man. Okay. Remember, level 7. We need to level up, guys. We need to level up. Leveling up means work. Right? Leveling up means work. So please, let's do this. Right? Alright, so that's 8, 9, and 10. Okay, so that is A, sorry people, that's a bracket. Maybe I need to write the 10, rewrite the 10. It's A minus 3B. I'm sorry for my handsome writing there. I know. Okay, there it is. 10 is A minus 3B minus C into 3B minus A plus D into 3B minus A. No, listeners, please go back to the first example of sign change. Okay, just a second. So hopefully we've all gotten down the problems then. Okay, remember this is squared. Okay, all right. So hopefully we've gotten them all down. Can I then, yeah, go back to the first example of sign change. Where was sign change first? Sign change was, yeah, I know Katlefo. I mean, you don't have to. I don't like it when people compliment me too much for my handwriting. I know it's romantic and handsome and stuff, so just, yeah, you can lay off the compliments. Thank you so much in advance and all of that stuff. Okay, look at this, guys, the sign change rule. Remember, guys, the sign change rule is not something that's new, right? You guys did it in grade 9, but I'm just obviously looking over it again. Please, the sign change rule will only apply when there's a minus sign for your bracket expressions only, guys. Only when there's a minus. When there's a plus sign, if there was a plus sign, we know that the expressions are the same. There's no need for sign change. We just take out the common bracket if there was a plus sign in between two same terms. You know what I mean? So the minute there's a minus sign, you see this is a to the power 3 minus 2, whereas this one is 2 minus a to the power 3. These brackets are not the same. So we make them the same. How? We change the sign before the bracket that we want to change its order. We change the sign. So if it was positive, it changes to negative. If this was negative, we change it to positive. So it's no longer positive 1, now it is negative 1. That sign change allows us to change the order of 2 minus a to the power 3 to a to the power 3 minus 2. This is grade 9. So then when we take the negative and we distribute it back, we would see that, oh, we still have this. Because if you take the negative and you times it by a to the power 3, you get the negative a to the power 3 back. If you take the negative, you times it by the negative 2, you get the positive 2 back. So this sign change rule is just another means by which I am able to write my brackets so that they are the same. Then I can take out a common fact. Are you with me? So hopefully we understand this sign change rule thing. It's not a mystery anymore. It has been revealed to us. Okay? All right. Good people, thank you so much. Please do the game challenge and then send my beloved grade 10 learners. Okay, this is grade 10. Grade 9s, I had a session earlier on. I will upload what I covered after I'm done here. I'll upload that thing, the session that I had with grade 9. Okay? And then, unfortunately, so like I said, grade 9, we're having you at 7 a.m. in the morning, every morning, grade 9. Then grade 10, we're having you at 8 o'clock every morning. Grade 11, we are having you at 9 p.m. at night. Then grade 12 at 10:30. Okay, that is standard how the sessions are organized and arranged. Those who are asking me to do other topics, not yet, guys, because I am covering the syllabus according to the annual teaching plan of the year. So for all grades, where I'm at is how far I've covered. If you want to see the previous live sessions I've had, you are more than welcome to go to my YouTube channel, which is called Maths is a Game. Go to the YouTube channel, Maths is a Game. You'll find all the sessions that I've done previously uploaded. Okay, so Bosi, you're asking when is grade 12? It's at 10:30 tonight. We had a session last night with the grade 12. Sorry, grade 12 is at 10:30 daily before schools open. We are having our sessions at 10:30. We are on the night shift. Grade 12, 10:30. Grade 11, 9 o'clock. Okay, grade 11, 9 o'clock. Grade 10, we have an 8 a.m. slot. 8:30, let's be more exact. 8:30 in the morning. All the time, grade 10, we have 8:30. And then grade 9 is always at 7 a.m. in the morning. I don't have grade 8 at the moment. We'll see until further notice. I will let you know when grade 8 can finally do the move. But for now, these are the sessions for the respective grades as we are holding them. Thank you so much for joining. Please do the game challenge and give me your sweet feedback in due time. I will like I said, Minence, I don't know, write down the session. What do you mean write down the session? Minence, you are asking what? Write down the session for what? You're welcome, Mampo. Please, guys, don't be scared to share the live session, and all generosity is also welcome on the platform, guys. Don't be scared. I think some of you are enjoying the sessions. Please don't be scared to be generous. I know this TikTok thing has a sweet gifting thingamabob that happens. So don't be scared of those things. Barbie, I do one-on-one sessions, but yeah, those one-on-one sessions, they are obviously at a certain price. So you need to contact me on the site and express your interest so that I can share with you. And then you can reject the sessions according to what you see. Because I do know there are lots of people who are doing these things. Some of them you pay and all of that stuff. So yes, the one-on-one though is definitely paid, because that means I'm going to zoom in to your specific problems and your specific challenges and help you out specifically. So this is general, and I have no problem actually doing this the way that I'm doing. Please guys, do support my live goal. That's also nice, when people can support the live goal when they are watching a nice session. I know we enjoy things for free, but even my life goal, it's not that hectic. I embrace all forms of generosity in all shapes, forms, and sizes. So don't be scared. Thank you so much. By the way, Oshama said, referring to time. Oh, all right. Okay. Like I said, I'll repeat that again. I said I do grade 9, 7 a.m. Grade 10, 8:30. These are morning sessions. Then grade 11, 9 p.m. Grade 12, 10:30 p.m. Okay, so hopefully you've heard me now for those sessions. And so far with grade 11, we've covered and done exponents and surds. We are currently doing equations. We started with quadratic expressions yesterday, how to find the maximum and the minimum. And I'm busy trying to upload the session that I did on the YouTube channel. The YouTube channel, guys, is on my bio. You can go there. You can fast track the previous live sessions I've done. Please subscribe and follow. And this is just another way of just showing some support. Tabs, I have not as of yet done a second session with grade 8 because of the attendance. But if you have interest in grade 8, just let me know, and then according to the volume of interest, I'll see. We can take it from there. Yeah. Okay, thank you so much. Dango. How?